We really are glad to see all of you here. It's a full room, and we really look forward to tonight's talk, Talking Climate in a Red State, with Dr. and Katharine Hayhoe. Dr. Hayhoe, thanks so much for being with us. Really appreciate it. So before I introduce our speaker this evening, I have an invitation. If you would like to know more about the work and the impact of the Riley Institute, I hope you'll come back to Furman this Saturday. If you're students, you can just walk over to Johns Hall 101 for one or both sessions of the Riley Institute that are presenting in the Riley Institute showcase that we have. Our 2 o'clock session focuses on our Diversity Leaders Initiative and how it helps build relationships and leverages deep dialogues to address community challenges across South Carolina. Our 3:30 session features 3 community challenges. Features 3 Furman alumni, actually, and Furman senior Owen Miller, who will talk about the experiences they have with the Riley Institute and how it has influenced their pathways. You can use the QR code on the screen to register to attend, or you can just show up. We're here tonight because the critical issues of climate change, they're just not going away anytime soon. And it's something that the Riley Institute has long had a focus on. Many of you attended 1 or 2 or all 3 of our Straight Talk sessions last fall entitled A New Climate Movement, Acting on Solutions That Work. You may recall that Katharine Hayhoe spoke via Zoom during that third night session. However, you may not be aware that in 2018-2019, that year, as part of Furman's year-long exploration of climate change, the Riley Institute worked with partners across campus to host activities to raise awareness and deepen our understanding around the impact of climate change. That year, we hosted a 2-day national conference entitled Climate Change is Real, Now What?, featuring former astronaut and head of NASA General Charles Bolden. And over the years, we've hosted other events exploring themes such as China's environmental crisis, the global race for clean energy, and what gives us hope for a heated planet. Tonight, we bring to you a world leader in the fight against climate change. Dr. Katharine Hayhoe is the Paul Horn Distinguished Professor and Political Science Endowed Professor of Public Policy and Public Law at Texas Tech University. She has a Bachelor's of Science in Physics from the University of Toronto and a Master's of Science and PhD in Atmospheric Sciences from the University of Illinois. In addition to her impressive academic credentials, she is the author of the best-selling book, Saving Us, A Climate Scientist's Case for Hope and Healing in a Divided World. She's also someone who has received numerous awards from Time, from Fortune magazine, from the American Geophysical Union, the United Nations, and more. All these honors recognizing her as a remarkable communicator, a leading thinker, an influencer, and one of the world's greatest leaders on climate change. She is the chief scientist of the Nature Conservancy, was the lead author of the 2nd, 3rd, and 4th National Climate Assessments, and her TED Talk, entitled The Most Important Thing You Can Do to Fight Climate Change, Talk About It. Talk About It has had over 4 million views. There are so many things that she is doing, but I add just one special feature in her biography. She's married to Andrew Farley, a pastor at a church in Lubbock, Texas, who is a graduate of Furman. So Dr. Hayhoe, you are already part of the Furman family, and we're so glad you're here with us tonight. Everybody, please join me in a warm welcome for Dr. Katharine Hayhoe.
Thank you so much for that kind introduction. Now, before we start, how does this sound? It's good, okay? At the back there, yes? Okay. I will try to stay close to this mic. So the title, Talking Climate Change in a Red State, begs one more credential that was not mentioned. For the last 15 years, I have lived in Lubbock, Texas. That's the home of Texas Tech University. And it is the 2nd most conservative city in the country. So if you can talk climate change in the 2nd most conservative city in the country, I think you can talk it anywhere. And now you may say, well, what's the first? It is not Greenville. It's Provo, Utah. And last November, I was at Brigham Young University to talk about climate change to the entire university. So yes, you can do it in the number one too. So you really can have these conversations. And that's what I'm here to talk to you about tonight. And as we go along, I'm going to be asking you a few questions, and you can ask me questions too. And at the end, we'll get to some of your questions. So if you take out your phone, and if you haven't yet silenced it, it's a good time to do it, and join Poll Everywhere. As we go along, like I said, I'll be asking you a few questions, and then you can ask me your questions, and here's the fun part. You can upvote the questions you most want me to answer. Because I know we're going to get way too many questions to answer. So if you upvote the ones you're most interested in, those are the ones we'll get to. So if you take a picture of the QR code, or you can type in pollev.com/Katharine. I don't recommend typing, though, because everybody always spells Katharine wrong. It's got 2 A's in it. If you do that, it will take you to the next poll. I see a few people still have their phones up, so I'll just give it one more minute here. Any phones over here? Nope, nope. Okay, it looks like, a couple more phones over here. Got it? Okay, phones down. Oh, called that one too early. There we go. All right. Now the first question is a question I have for you. I want to know who you are. Of course, students answer first. Are you a student? Are you faculty or staff? Are you an alum? Are you a community member? Or are you just somebody who happened along? And we do have a few of those, as you can see. So it looks like we've got 75, 3/4 of people here are students. Fits, mostly students, mostly students. Some faculty and staff, a lot of community members. Well, sort of feels a little bit like election night, but I think we're going to call it 75% students. Okay. So as you go along, you can keep your phone handy, because at any point, I may ask you a question, or at any other point, if you have a question for me, I'm going to leave the questions open, and you can type a question in here at any point, or you can go there and see what other people have been asking, and then you can upvote, give a thumbs up to the ones that you're interested in. I'll remind you of this as we go along, don't worry, but this is going to stay open as we continue. So I'm a climate scientist. My degrees are in atmospheric science and physics. But I am now, if you caught this from my bio, I am now in a political science department. And you might say, what is a climate scientist doing in a political science department? There you go. Look, we have our first question already. Back 25 years ago, this is actually coincidentally the year I decided to become a climate scientist. Back 25 years ago, this is what the political landscape of the United States looked like. The median Democrat was closer to the median Republican than they were to people at the tails of their own party. Most people in the United States were in the middle, 25 years ago. Over time, 2011, 2017, it shifted. And in 2017, that was when Hillary Clinton was running against Donald Trump. They surveyed, these are data from the Pew Foundation, they surveyed only people who voted in the election, which you know is only about 30% of the population. When you only ask people who voted in the election where they fell on the spectrum, it looked like this. The people who are voting are way out to the tails of the distribution. In fact, there are more people at both ends of the spectrum, both, not one, than there are in the middle. And today, and for the last 10 years, if you look at the date on this news article, it's from 10 years ago, the United States is more politically polarized than it has been since the Civil War, and you know how that went down. As a result, people who identify themselves, and this is a key word, identify, people who base their personal identity on their political affiliation rather than their relationships with other people or what they're good at or their faith or some other thing like that, if they base it literally on their political identity, are starting to view each other less as fellow citizens and more as enemies who represent a profound threat to their identity. And when this mindset develops, compromise is viewed as weakness or betrayal, and their gain is our loss. In other words, when people are polarized, they're willing to cut off their nose to spite their face. That's the world that we live in, and we've been living it now for over a decade. As Calvin said to Hobbes quite a few years ago, these are interesting times. We don't trust the government, we don't trust the legal system, we don't trust the media, we don't trust each other. We've undermined all authority, and with it, the basis for replacing it. Hobbes, always the voice of sense, says interesting is a mild way of putting it, and Calvin says, yes, it's like a 6-year-old's dream come true. And this is an old cartoon. So what does this have to do with climate change? Why did she start to talk about climate change by talking about political divisions in the United States? It's not because a thermometer gives you a different answer depending on how you vote, right? A thermometer is a thermometer. It gives you the same answer no matter how you read it. But that's not what we think. So 10 years ago, they surveyed people in America, and they looked at what people were most divided on. And back 10 years ago, the number one issue that people were most divided on was whether or not they approved of the current president. And that should be the issue that Republicans and Democrats are most divided on, right? That should be it. Do you support the leader of your party or the other party? That should be the number one issue. Okay, that's totally fine, right? Now let's look at the other issues. Number 2, 10 years ago, was climate change. Then you had gun control, and under that you had, do you trust scientists? It's kind of horrifying. And then there was the Arctic and weather, because that was when people started talking about the polar vortex and all the weather. And then you've got the really traditional hot button polarized issues, abortion and death penalty. They're down at the bottom of the list. So that was 10 years ago. Where are we now? Take a guess. Well, right before the COVID pandemic hit in February 2020, this is what it looked like. Now, what this is a list of issues in terms, ranked in terms of the width of the gray bar. The width of the gray bar shows how far apart Republicans and Democrats are on a specific issue. And I know this font is a little bit hard to read because it's tiny, but so I will read it for you if you can't. What issues are up at the very top? What issues have the widest gray bars? Climate change and environmental protection. In 2020, they were right up there at the top. Under that, they have guns, military, immigration, education, healthcare, race, terrorism, poverty, and so on. Then the COVID pandemic happened. And one of my favorite cartoons, because I do like a bit of black humor, is a cartoon of 2 medical professionals standing there with a chart saying, well, if we just tell the American public the facts, everybody will do the right thing, right, about COVID. And then behind them, there's climate scientists rolling on the floor laughing. So let's fast forward a year into the pandemic. And here we have our gray bars again. The widest gray bars, again, are the most polarized issues. And what do we have at the top? We have addressing issues around race, because, of course, Black Lives Matter came to the forefront that June. Dealing with global climate change and dealing with the coronavirus outbreak. And where are we now? Well, climate change has again continued to climb back up to the top. Now, the United States is the location, the country where this is most evident. But when you look around the world, you see it's not only happening in the US. So this first study here, and I will translate this because often, meta-analysis of determinants and outcomes is a little difficult to parse. They looked at 56 countries, and they found that what people thought about climate change was determined by their values, their ideologies, their worldviews, and their political orientation, not their education. And in fact, the biggest correlation between what they thought about climate change was with their political affiliation. Then, another interesting study down below found that in general, across every country they studied, when people were more politically liberal, they were more concerned about climate change. But when they were politically conservative, they were less concerned about it. And in the United States, it actually got reversed. So at this point, you might be wondering, well, what are we supposed to do about this? You mean we have to fix our political system, and not just our political system, but everybody's political system? We have to fix everybody's political system before we can act on climate change? This is a tough nut to crack. Now you understand why a climate scientist is in a political science department. Because we've known for a really long time exactly what's happening to this planet. But there's more to it than the politicization. Our brains are not good at understanding the climate issue. So let me switch gears now and talk about it from the other angle, from the scientific angle. Our brains are really good at remembering weather, and I want to put this to the test. Get out your phones, and I want to ask you, just give me one word, not two words, just one word. I want to ask you, what's the craziest weather event you ever experienced? Give me one word. If you're going to say Hurricane Ian, you have to use like a space, like don't put a space in between them, put like a dash in between them or something. There we go. Okay, Texas. Yeah, Texas actually is basically one extreme weather event. That is what Texas is. Texas gets more extreme weather events than any other state in the country, so that is a valid answer. All right, we've got tornadoes, hurricanes, floods, polar vortex, superstorm Sandy, Sharknado. Somebody really experienced Sharknado. The Discovery Channel wants to talk to you. Hail, volcanoes, hailstorms, heat waves, torrential downpours, blizzards. Everybody has a weather story, right? We all have a weather story. And if you don't have a weather story, if you're like the one human who doesn't have a weather story, come to Texas for 1 week. You will have a weather story. So everybody has a weather story. Why? Because our brains are built to remember weather. All right, I'm sorry, you lost your chance now. Going back to the questions. Because weather is what our brains are built to remember. We can remember weather. Weather is a single event at a single time. In fact, the way I think about it is that weather is the ups and downs, the heat, the rain, the drought. But what is climate? Climate is the long-term average of weather over at least 20 to 30 years, and our brains are not built to remember climate. Can you add up the temperature here in Greenville every day of the year for 20 to 30 years in your head and fit a trend line to it to determine whether it's going up or down? I don't want to see any hand up, because if you do it, I'm not going to believe you. I can't do that without a computer, and I'm a climate scientist. We all can remember weather like this, but climate is not something that's intuitive to us. And so when it's hot outside, people are like, oh, global warming. And then it's cold outside, and they're like, oh, where's global warming now? Right? That's because that's the way our brains are wired, and they're wired against us on this issue because we are not computers or machines. We can't figure out climate. The way I think about it is weather's like a tree. It's what happens in a certain place at a certain time, but climate is the long-term average over at least 20 to 30 years. It's like the forest. So we could describe the tree, but if you had to remember every tree in the forest, we just can't do that. Our brains aren't built that way. So does that mean that climate isn't important? No, in fact, climate is critically important because our entire society is built on the assumption that climate is stable. And when I say our society, what do I mean? I mean our buildings, our food, our water, even the clothes we have in our closet is based on climate. I have a really nice giant Canada Goose parka from Canada, and believe me, I wear it once a year in Texas. I don't even need to. But like if it's like trace of ice or snow, I'm like, yes, parka day. So we assume the highs and lows we've seen in the past are a perfect predictor of the future. Where do we get the 100-year flood zone from? The past. Where do we get our building codes from? The past. What type of food we grow? Where and when and how? We get that from the past. Whether we're going to need an air conditioner or not. You might say, who doesn't need an air conditioner? I grew up in a house in Canada without an air conditioner. But now, my parents put one in about 10 years ago because it's a lot hotter than it used to be. Flood zones, whether we have a snowplow or not, all of this is built on the assumption that what we know about the past is true for the future. Planning for the future based on the past, though, is like driving down the road looking in the rearview mirror. And you might say that sounds ridiculous. Who would do it? If you live in Texas, you can get away with it. There are some roads that are so straight that as long as there's no big armadillo in your path, you could successfully drive down the road looking in the rearview mirror. Why? Because it's straight. And for the history of human civilization on this planet, the temperature of the planet has been as stable as that of the human body. So over the course of a day, your body temperature goes up and down by a few tenths of a degree, and that's normal. Over the course of human civilization, the last 6,000 to 8,000 years, the average temperature of our planet has gone up and down by a few tenths of a degree. That's normal. But today, the planet has warmed by 2 degrees Fahrenheit. What happens if your body warms by 2 degrees Fahrenheit? You feel achy. You're running a fever. You take some Tylenol. You might call the doctor. You don't feel like you're thinking straight. You maybe need to go take a nap. That's what's happening today. So we've been assuming the road was straight, and it was straight. But if climate is changing today, then the long-term average and our highs and lows cannot predict the future. Do we still have cold waves? Yes. Do we still have wet and dry and hot and cold? Yes. But they're changing. We're seeing more extreme heat than we used to see. We're seeing more extreme rain than we used to have. Basically, we are on a curve, and our wheels have hit the rumble strip already. We have to look ahead to the future. That's why climate matters. Because today, climate is changing faster than any time we have seen, and that's what this is about. It's not about the planet itself. The planet could be a frozen ball of ice, and it would be just fine. But we wouldn't be just fine. It's about us living things. We have never seen it changing this fast. It's changing up to 50 times faster than between the last ice age and today. That's crazy. Plants, animals, humans, we can't adapt that fast. Now, when we start talking about it changing, people are quick to say, and you will hear people here say that because 49% of people in South Carolina do not think this is happening due to human activities. When we see this happening, people often say, well, how do we know it's not the sun or natural cycles or volcanoes? What people don't realize is that's what we, climate scientists, study. We study natural reasons why climate has changed in the past. In fact, we spend more of our time studying natural climate changes than we spend studying human causes because they're more complicated, harder to decipher. So when we look at the sun, we know that over the last 50 years, the sun's energy has been going down, not up. So if the sun were causing us to change, we'd be getting cooler, not warmer. It can't be the sun. What about natural cycles? Natural cycles like El Nino, all they do is they move heat from north to south or east to west or ocean to atmosphere and back again. So when we have a natural cycle, one part of the world's getting warmer and the other part's getting cooler. And we've had natural cycles before. We had something called the medieval warm period back in the day. And using natural thermometers like tree rings and ice cores, we can actually make a map of what the world looked like during the medieval warm period. Do you want to see it? It's pretty cool. Oh, damn it. I took that slide out. Well, let me tell you what it looked like. You have this red, hot, warm spot over the North Atlantic. And over Siberia, you have a big blue cold spot. If you were in Siberia during the medieval times, it was the medieval cold period. So it just shows how Western European-centric our culture is, that we call it the medieval warm period as if it was global, when it wasn't. But what happens when you look at the world today? The entire world is warming, the whole thing. The atmosphere, the ocean, the land surface, the ice is melting. It is all warming. That's how we know it's not a natural cycle. And lastly, people sometimes say, well, doesn't one volcanic eruption produce more pollution than humans do in 30 years? Volcanic eruptions do produce pollution. They produce sulfates that cool the Earth. They act like an umbrella reflecting the sun's energy back to space. And so big volcanic eruptions cool the Earth for a little while. They don't warm it. When we cross all of these off the list, we're only left with one thing. The fact that for the last 300 years, we've been digging up and burning coal and gas and oil. And when we burn that stuff, it produces heat-trapping gases that are building up in the atmosphere, wrapping an extra blanket around the planet. And if someone snuck into your room at night and put an extra blanket on you, what would happen? You'd start to heat up, right? You'd say, hey, I didn't need this. I'm too warm. That's what's happening to our planet. So that's why today climate is changing. We've looked at every natural factor, and we know it is us. It's not just changing at the global scale, it's changing across the United States, and it's changing in South Carolina too. Now, can we still have cold years? Of course. That's weather. From one year to the next, that's weather. But decade by decade by decade, it's getting warmer and warmer, and that is climate. A lot of people call this global warming, but I prefer to call it something different. I prefer to call it global weirding. Because no matter where you're from, things are just getting weirder. And it might not be temperature. Now, what we do see, though, is we do see that our heat waves are getting more intense and more dangerous right here in South Carolina as well as around the world. So we do see that heat waves are getting worse, but we also know that our heavy rainfall is getting more frequent. Why? Because warmer air holds more water vapor. So when a storm comes along, there's more water vapor for it to sweep up and dump on us than there was 50 or 100 years ago. And what else are we doing? We're also paving the heck out of our planet, which means that when that water falls, there's nowhere for it to go, and our flood risk is increasing too. We know that sea level's rising. Why? Because warmer water takes up more space, and did you know that over 90% of the extra heat being trapped by that blanket is going into the ocean? But land-based ice is melting, and all that water is also going into the ocean. And so we're seeing sunny day flooding increasing, and a report that NOAA published last year found that of all the places on the Atlantic and Gulf Coast, Springmaid Pier near Myrtle Beach had the most flood events. That is in South Carolina. Who's been to Springmaid Pier? A few people. You know where that is. And then there's this type of storm that gets its energy from warm ocean water, and that is a hurricane. And as the oceans have been warming, they are causing hurricanes to intensify faster, to get stronger, and to dump a lot more rain. Now, have we had hurricanes before? Of course we have. Have we had heavy rain and floods and heat waves? Of course. What's happening is climate change is making them worse, stronger. In the case of hurricanes, not more frequent, but it is making them more damaging, and that affects all of us. It's literally affecting the water we drink. It's affecting the air we breathe. It's affecting the food that we eat. It's affecting the infrastructure and the buildings and the roads that we use. Like I said before, it really is not about saving the planet. The planet will be orbiting the sun long after we're gone. It is about saving us living things on this planet that are perfectly adapted for the climate we had in the past. Yet today, it's like the rug is being pulled out from under our feet, and it's changing faster than any time. So at this point, knowing what's happening and how it affects every aspect of our lives on this planet, you kind of end up here again. So politically and socially, we're headed in that direction. And then in terms of the well-being of our food and our water and our infrastructure and our health, we're headed in this direction. How do we bring these two together? Where do we start? And so often people turn to the science and they say, well, if I just load up my wheelbarrow of facts, I will tell people about the Greenland ice sheet. I will tell people about the polar bears. I will tell people about all of the things that are happening to global temperature. And believe me, we scientists have the facts. If you go to Google Scholar that archives scientific articles, there are 2.6 million scientific articles about climate change. If you go to the Intergovernmental Panel on Climate Change reports, a new one just came out 2 weeks ago, you could start here and you could pile those reports all the way up to the ceiling. Single-spaced 10-point font. And a couple of years ago, I and some of my colleagues said, all right, well, we've got 2.6 million papers, but over the last 10 years, there were 38 of them, 38 over 2.6 million. There were 38 the last 10 years that said that either climate isn't changing or it's not humans. So we said, could they know something that the rest of us don't? We wanted to know. That's what scientists want to do. We want to know. So we took those 38 studies and we recalculated every single one of them from scratch. So it was like doing 38 separate studies, but we did them all together. And what we found when we recalculated every single one of them was that each one of them had at least one error, in some cases a mathematical error, in some cases an error where they left out a factor that they shouldn't have, or they made an assumption that was incorrect, that when you corrected that error, it brought it in line with the scientific consensus. And we try to communicate this. A couple of years ago, I was part of a letter that 11,000 scientists wrote saying it's bad and we need to fix it. We've got scientists who have been saying this since the 1800s. Did you know that the original scientists who determined that digging up coal and burning it produced heat-trapping gases, they did their work in the 1850s? In the 1890s, Svante Arrhenius calculated how fast the world would warm if we doubled or tripled levels of carbon dioxide in the atmosphere. By the 1930s, Guy Callender was riding around the world collecting temperature data, showing that the world was already warming because of burning fossil fuels. This is how long we've been beating the drum. And today we're trying to do it every way we can. We're trying to do it on social media. Scientists are cheating themselves to bank doors. Scientists are doing everything they can to get the word out. But here's the problem. People don't truly have a problem with the science. Now you might say, but hang on, Catherine, didn't you know that everybody says it's a natural cycle or it's a volcano or it's the sun? Yes, just look at my Twitter replies. On any given day, I have people telling me that. I'm tempted to reply to each one with that Macaulay Culkin sort of like, but I don't. Because every one of them is like, haven't you heard? And I'm like, yes, I have heard. In fact, that's the third time I've heard today. But what those are excuses. Because if people truly had a problem with the basic physics that explains how heat-trapping gases trap heat, that we've known since the 1800s, and how that affects the dynamics of our weather patterns, they would also have a problem with airplanes flying and stoves heating food. It's the same physics. And I know on the internet you can find almost anything, so I'm pretty sure you probably could find one or two people on the internet who don't actually think airplanes fly, but most people do. So Dan Kahan, when I show you other people's work, I like to show you who they are. Dan Kahan's at Yale, and what he's done is he's studied, is it scientific literacy that's holding people back? So do we just need more scientific education? And he found that people who are most educated on science are not most concerned about climate change. Rather, they are most polarized. The more educated we are, the more polarized we are. What? So he dug into that again in a second paper, which I will translate here. He found that being smarter doesn't make you more accepting of science. It just makes you better able to cherry pick what you need to prove you're right. And in my book, Saving Us, I give a practical example. My husband and I both have PhDs. His is not from Furman. His undergrad degree is from Furman. We both have PhDs from University of Illinois. And when we have an argument over whether you can eat the yogurt if it's 2 days past its due date, we pull out the peer-reviewed articles to have that argument. But we're not doing it to see who's right. We're doing it to prove that we're right. I'm not trying to allow him to convince me it's okay, I should throw it out. I already know I can eat it. And I'm going to find the evidence to show him. Right? So that's a pretty low-stake thing. And I'm sorry, it is true, we do pull out peer-reviewed articles to argue. That's a pretty low-stake thing. But my point is that we are using our educational ability not to change our own minds or to be open to our minds being changed by somebody else, but rather to prove that we're right. And guess what? We all do that. And the smarter we are, the better we are at it. Tali Sharot is a neuroscientist, and what she says is our brains are programmed to get a kick out of information. That's the way we humans function. But when we give people new information, they typically only accept it if they already believe it. Or I would venture to say if they don't care. So if somebody told you something new about dark matter, do you have a strong ideological identity position on dark matter? Most people don't. A few people do, but most people don't. So if somebody told you something new about dark matter that completely sets what we knew on its head, you would probably say, oh, okay, sure, right? Or if somebody told you something new about something you're already passionate about, you'd be like, yes, more ammunition, right? But if somebody tells you something that you don't agree with, she says, our brain shuts off. And George Lakoff, who's a cognitive linguist, he says, we've been taught a false and outdated theory of reason that facts alone will set you free. Now, of course, facts matter. Like you could say, I don't believe in gravity, but if you step off the cliff, you're going down, right? But to be meaningful, he says, they have to be framed in terms of their moral importance. If the facts don't fit the frames in your brain, the frames stay and the facts go. And this is the way we operate as humans. I feel like I should have that face again here. I don't, but you can picture it. So it isn't lack of education, it isn't lack of knowledge, it isn't lack of intelligence. The smartest people are the most divided. So what is going on? How do we have positive conversations about this? Well, first of all, I want to emphasize we don't fall into two groups on the issue of climate change. We fall across a spectrum. And this spectrum is quite different than what you probably thought it looked like, because over 50% of people are already alarmed or concerned about climate change. When you include the cautious, we're up to over 70%. So the majority of people are on this side of the diagram. But only 8% are activated. Worried doesn't equal activated. The whole world could be worried, but if nobody's activated, it doesn't matter if you're worried or not. So the goal is not to make more people worried. The goal is the fact we already have 70% of people worried, but only 8% of those people are activated. The goal is to activate people. And if they're already worried, they know about the polar bears already. They already know about the ice sheets. They know about sea level rise too. More information about that is not going to activate them. They already know it. But what can you do about the polar bears or sea level rise? Most people would say nothing. So that's the first thing I want you to take away from here. But then I want you to take away one other thing. When we go back to here, what's the secret to changing people's minds? There is a secret, and it was really interesting because I spoke today at lunch to a group of students who'd all read my book, Saving Us, and I said, well, what was the most interesting thing you took away from it? And about half the students mentioned some version of this, that they learned that there's one group that we can't. And that one group is typically the first group we gravitate to when we want to change someone's mind. It is the group of people who are the loudest. The people who are always posting on Facebook how it's not true. The people who are always sending you articles about how it's not true. The people who are always bringing it up at Thanksgiving dinner about how it's not true. I'm talking about the people we all know. I've only met one person in my entire life who didn't have a relative like that. And when I said that today, a student was like, oh, so they have no relatives at all? People who are dismissive have literally built their identity on rejecting the reality of this issue. And so when someone who's dismissive hears me say, it's not volcanoes, they don't actually hear me say it's not volcanoes. They hear me say, you're stupid and you're bad. And so they don't listen. And I'm not saying that. As you can just see, I've said the smartest people are the most divided, right? So chances are, if someone's dismissive, they're probably quite smart, and they could be quite educated. But because their identity is tied to it, they can't have a conversation because every conversation about the topic is a threat and an attack. But the good news is, most of us, over 90%, almost 90% of us, are not dismissive. And there, we can have a positive conversation if we talk about the real problems. What are the real problems? The real problems are we don't understand why it matters, head to heart, and we don't understand what we can do about it, heart to hands. The first one is something that's known as psychological distance, and we're really good at psychological distance. Not going to ask for a show of hands or a vote, but who stands up every 30 minutes that they're working at a desk or the computer like you're supposed to? Do you doubt the science on that? Do you think it would be better if you did? Yeah, probably. But we just don't do it because we see it as a far-off risk. Oh, that'll matter to me in the future. It doesn't matter now. Or we see risks as being far away in space, over there, not here. Or, abstract, global average temperature, not what's happening to my life. Or that just matters to those type of people, not to me. I'm not that type of person. And we see this with climate change. So this is a map showing public opinion across the United States. Each little unit there is a county. I've highlighted Greenville County right there, so you can see the numbers. And anywhere that's orange is more than 50% of people said yes. And the darker orange it is, the more people said yes. If it's blue, it's less than 50%. So you ask people, is global warming happening? And most people will say yes. And in fact, almost an identical number of people are worried. And then you ask them, will it harm plants and animals? And most people say, yeah, sure. Where's the psychological distance there? Non-human species. Will it harm future generations? Sure. Where's the distance there? People in the future, not now. Will it harm people who live in developing countries? Where's the distance there? In space. They live over there, not here. And then the researchers ask this question. Will it affect you? That's psychological distance. If you want to explore this online, you can. It's very interesting. They asked a lot of other questions too. So we have to talk about how it's not just in the future, it's now. It's not just over there, it's here. It's not just global average temperature, it's what's happening where we live with the heat waves and the sea level rise and the hurricanes, and it's affecting my life. But we also have to talk about what solutions look like. Because people are willing to change if they think what they do makes a difference, and today, nobody thinks what they do will make a difference. You know, I only travel in person, and the reason I was here virtually last time was because I only travel when I have enough events in one place that it's as if I'm driving to each event in my little plug-in car from where I live, in terms of the carbon footprint. That takes a lot of work to organize. And so I spend so much time and so much effort organizing these bundles of travel to be very efficient with my carbon and my time. And then I hear that they're running 3,000 empty flights just to keep their gate assignments. And I'm like, why bother? Talk about a lack of efficacy. All the blood, sweat, and tears I put into what I do, and empty planes flying through the sky. How can I make a difference? So how do we tackle this psychological distance, and how do we help people see that there's real solutions that are actually good for us? It turns out that these maps, there's one more map I haven't showed you, and the map is what we're not doing. Now, this might sound so trivial that you're like, I just skip right over that step. What is that step? Well, we left off here, right? Do you think it's going to affect you personally? And then they ask one more question. Do you ever talk about it? Yeah, I heard somebody sort of choke in the front row. What's the connection? Well, what do you talk about? You talk about what you care about, right? And if you don't talk about something, why would anybody care? And mind you, this is occasionally, right? It's once in a while. It's not regularly. So often, though, I know there's a bit of a Calvin theme going on here. So often, though, we're like, okay, but I have these conversations, and we just end up shouting at each other. Like, Susie the scientist shows up with all the scientific publications, and we just have a big argument about it. There's Susie with all her science. And so we just end up digging a trench instead of building a bridge, and the conversation ends something like this. Does this feel familiar? Have you had a conversation like this? Or these days, it sometimes ends like this, because this is depressing stuff. I'm not talking about that. I am not talking about starting with an argument. I'm not talking about starting with what you disagree about. And I'm not talking about starting about the hopeless nature of the world. I am talking about having a conversation about what's happening to us here that matters to you and me, and what we can do to make a difference. We care about climate change because it affects things we all care about. Who doesn't need water? Everybody. Who doesn't need food? Who doesn't want a safe place to live? Who doesn't want good health? Everybody wants these things, and these are the things affected by climate change. So a little while ago, I was speaking to people in Iowa, and somebody said, okay, all right, I get that, but you still haven't answered my biggest question, which is, how do I talk to people in Iowa about polar bears? I said, well, unless there's a secret population of polar bears in Iowa that I don't know about, you don't. You don't talk about polar bears in Iowa. Now, of course, there could be somebody who's really, really into polar bears in Iowa. In that case, you could. Most people aren't, though. When I'm in Texas, I talk a lot about cotton and farming with Jack, who hasn't had a decent precipitation year since 2005. And I listen to him tell me about that. When I'm talking to my friends from California, I listen to them tell me about how their kids couldn't play outside a whole summer because of all the smoke in the air. And imagine what it was like keeping toddlers inside all summer. When I'm talking to my friend who has a beach house in the Outer Banks, I listen to what happened last time there was a high tide and last time there was a hurricane, and she's telling me what's happening where she lives. Talk about what's happening in things that affect people's lives, things that matter to them. And we can start conversations with things that we have in common with people. So do an inventory of yourself. I'm a scientist, so I can certainly talk to people who like science. A lot of people do. I'm from Canada, so I can talk about what's happening in Canada. I live in Texas, which is an extreme event all by itself, as someone said at the beginning. We have more extreme weather events than any other state, and we always have something to talk about in Texas, the latest ice storm, the latest flood, the latest haboob. I love to ski, and you need snow for that. I like beach vacations, and you need sea levels to stop rising to keep on having those. I'm a mom, so I talk to other parents about the future of our kids. I'm a Christian, so I talk to other people who share my faith. I've started conversations by beginning with a shared love of knitting. I've begun with a shared love of wine. I've begun by talking about gardening or Rotarian values. Whoever you are, you have something in common with other people that can connect directly to why climate change matters or what solutions look like. And so take out your phones again. I haven't forgotten about it. I'm getting you warmed up for the final questions here. Take out your phones again. And this time I want you to give me a single word, just one word. Who are you that makes you the perfect person to care about climate change? I might answer scientist, I might answer mother, I might answer skier. Savage, that's a good one. Human, farmer, student. I love that. Communist and Republican. I love the juxtaposition of those two things. That's phenomenal. And that really makes the point, doesn't it? So I love that human is rising to the top, but I would point out that there's no right answer here, and whoever we are, we're the perfect person to care. We don't all have to be called Nick. We don't all have to be an archaeologist. We don't have to live in Tennessee. In fact, most people here are not from Tennessee. Oh, a few people are. There we go. So whoever we are, we're the perfect person to care, and we can talk to other people. Finally employed, that's a good one. We can talk to, now there are some problems coming up here. I am not qualified to deal with some of those issues. You may want to talk to a professional about some of those issues. But you get the point, right? Whoever we are the perfect person to care about these issues, and we can have conversations with other people who have those. We're almost at the questions now, but not quite. All right. Last section, then we're getting to the questions. So don't forget to look at the questions and upvote the ones you most want me to answer. And don't forget to put your questions in there. I got about 5 minutes. So talking about how climate change affects us and what we can do to fix it, we can talk about solutions, and that's what I want to end with, is what do solutions look like? Now, solutions are complicated, but they're easy to understand if you just picture a swimming pool. The swimming pool is the atmosphere. And way back at the beginning of the Industrial Revolution, we had just the right amount of water in our swimming pool so our toes just touched the ground. It's an above-ground swimming pool, to be clear. But we stuck a hose in the swimming pool, and ever since the Industrial Revolution, we have been turning the hose up every year. During the first year of the pandemic, we turned it down 7%. And then we turned it right back up again. So not only is the water going up, it's going up faster and faster because more and more water is coming out of the hose every year. So what's the first thing we have to do? We have to turn the hose off. That's the first thing. But our pool has a drain, and that drain is nature. Nature wants to take carbon out of the atmosphere. And we've calculated at the Nature Conservancy that that drain could take up to 1/3 of our carbon emissions out of the atmosphere. By investing in nature, trees, coastal wetlands, grasslands, smart agriculture. So we have to make the drain bigger, but there's one more thing we have to do too. The water in the pool is so high that our toes don't touch the ground anymore. We have to learn how to swim. And that's adaptation and resilience. So what do these look like? Turning off the hose looks like efficiency. We waste so much energy. 67% of our energy is wasted. So 67% of the hose is just efficiency, which saves us money. And what's the rest of the hose? Clean energy. What does making the drain bigger look like? Smart agriculture, forests, ecosystems, taking carbon out of the atmosphere and improving our soils and protecting biodiversity and filtering our air and water. Those are win-win-wins. What do resilience solutions look like? Solutions that green low-income neighborhoods to protect them from heat during heat waves and clean up their air and improve people's health and provide a place for water to go when it rains and address socioeconomic inequalities. Oh, and those trees take up carbon too. So there's solutions out there that are good for us. And we're doing a lot of those right here. So did you know that the Nature Conservancy is partnering with Greenville Water? Greenville Water last year was voted the best tasting water in the country. Yeah, you're pretty lucky because I tell you Lubbock, Texas, that would be the least best tasting water in the country. You have the best tasting water in the country, but you want to keep it that way. So using nature to filter that water is the best way to do it. And so part of what the Nature Conservancy is doing here in South Carolina with Greenville Water is partnering in controlled burns to ensure healthy ecosystems that continue to filter the water for the city. That's pretty cool, isn't it? Yes. Heavy rainfall is increasing, but installing rain gardens and green infrastructure soaks up that water when it falls, as well as providing green spaces in neighborhoods. What about along the coastline? Sea level is rising, but when you build living shorelines with oyster catches, you can actually help to protect the coastal wetlands and the beaches. So there's real things that real people are doing right here in South Carolina to turn off the hose, make the drain bigger, and learn how to swim. And they're helping people today as well as tomorrow. Because when we look at climate solutions, they do a lot of things. They give us cleaner air and water. They protect us from disasters. They help us grow more food. They provide more affordable energy. Solar energy is currently the cheapest form of energy in the world right now. Now, people might say, well, the sun doesn't shine at night. Yeah, I know that. That's why there's no one solution to our energy issue. We need it all. We need storage, we need wind, we need solar, we need hydroelectric. We need things like heat pumps and geothermal energy. We need it all. It reduces our inequalities, it makes our cities safer, and it gives us a more stable world. Who's on board with these solutions? There's entire countries that are on board. There's even a country, Bhutan, that's carbon negative. They take up more carbon than they produce through trees. There's corporations that you might have heard of, not just the Patagonias of the world, the Microsofts and Apples and Googles too, and Walmarts. There's churches and army bases and community organizations that are getting in on this. There's young people who are leading and speaking out and advocating for climate action. There's the changes that we make in our own lives, what we drive, how we eat, what we put on our roof. That is my roof, there. And when we look around the world, we see the world is changing. By 2025, more people will be getting their electricity from renewable sources than from fossil fuels. We often picture climate action like a giant boulder sitting at the bottom of an impossibly steep cliff with only a few hands on it. And we think if I had my hand, it is never going to budge, so why bother? But when we look at what people are doing here at Furman, what they're doing at USC, what they're doing at Coastal Carolina University, where I was yesterday, when we look at what cities are doing, when we look at what businesses are doing, what churches are doing, when we look at what everyone is already doing, we realize that giant boulder is already at the top of the hill. It is already rolling down the hill in the right direction. It already has a million hands on it. And if we put our hand on it, if we encourage others to add theirs, it is going to go even faster. And that's what it has to do. So what's the first step? What's the first domino? The first domino is, remember that dark blue map? Something so simple we skip right over it, and that is having a conversation about why it matters and about what solutions look like. That is the first step, and it is a step that every single one of us can do. Because the conclusion of all those IPCC reports I talked about, the ones that you could pile up all the way to the ceiling, the conclusion is crystal clear. Every action matters, every bit of warming matters, every year matters, every choice matters. We matter, you matter, and together we truly can change the world and ensure a better future for every single one of us, no matter where we fall on the political spectrum, because whoever you talk to, regardless of how they vote or where they live or what they believe in or don't, everyone wants a better future. And the only way we're going to get there is if we tackle this issue together. So our conversations are not intended to argue with people. They're not intended to dig trenches. They're intended to say, let's bring people into the conversation by beginning with something that we both care about. And I've even done this. We tested this with 1-minute videos talking about the free market and climate solutions, talking about national security and climate solutions, talking about the Christian faith and climate solutions. And when you aired these videos in purple districts on YouTube and Facebook, Republican opinions changed twice as much as Democrat opinions because we're speaking their language. So we can have these conversations, and the science shows that they actually work. And who's the best person to have them? Not me. Scientists are number 2. You know who the best person to have the conversation is? You. People we know are the most effective messengers on climate change. We can tell people that whoever they are, they're the perfect person to care because of who they are. And if they don't realize that our job is not to argue with them or try to change them, it's to help them connect the dots between who they love, what they love, where they already love, how climate change affects that, and how climate action benefits them. So at this point, the only question I have left is, what are we waiting for? Go out and have that conversation today. Thank you. So we have time for just a few questions, and you've been busy. You can still do a little bit more. We've got 38. You are. Okay. This is a little competitive, isn't it? I sort of feel like I'm spinning a wheel, and then oh gosh, we're moving around. What are some of the worst things? Oh, I like that one. I'm going to say it quickly before it disappears. What are some of the worst things the average person is accidentally doing? Accidentally. Well, you probably know my answer. One of the worst things you're accidentally doing is never talking about this issue. That's one of the worst things. I bet you didn't think I was going to say that, did you? We also often don't realize how we can influence other people. So even if we are doing a lot ourselves, we aren't sharing that with other people. It turns out that the number one predictor, for example, if somebody has solar panels, is if a neighbor has them. The number one predictor of whether we decide to try something personally, like, driving instead of flying for a vacation, or biking to school instead of taking a car, or trying a plant-based meal. The number one predictor is if someone else we know is doing it and talks about it. So you probably expected me to say, we eat too much meat, and we do. We fly too much, and we definitely do. But my answer to the number one thing we are accidentally not doing is we just aren't having conversations about why this matters. And we can fix that. In a region that relies heavily on natural gas and coal, let me remind you where I live, in Texas, home of the oil and gas industry. In a region that relies heavily on natural gas and coal, how do you start a conversation with people whose livelihoods depend on these consumable resources? Well, I had to confront this myself a number of years ago when I was asked to speak to the board, the leadership team of a big oil and gas company. And my motto is, if you can't find something that you agree on, you shouldn't be having the conversation. So when this invitation came through, I had to think about it. I was like, well, what do we agree on? Where could I start? And I was thinking about it sort of as I go through my day, and I was doing the dishes that night, and it dawned on me that I am profoundly grateful for fossil fuels. Imagine living 300 years ago. First of all, I'd likely be dead. The average lifespan 300 years ago in the most developed country in the world at that time, the UK, was 40 years. I would not have access to electricity. I would not have access to education. My life would be the endless drudgery of getting water, getting food, making food, and then doing laundry once a week when it took all day, even though people only had 2 outfits. And so I realized I am actually profoundly grateful for fossil fuels. They have lifted us, all of us, out of grinding, back-breaking labor. They've extended and doubled our lifespan. But just as you no longer feed a teenager on formula, in the same way we can say thank you, but it's time to move on. So I went to speak to the oil execs, and I started off with a picture of my great-grandma Lucy. In 1890, she was wearing a giant hat, a full-length dress, sitting in a buggy, driving a horse. Then, the next picture was of my grandma Lucy 15 years later. Short hair, short skirts, 2 children, and a giant car. Her life changed radically for the better because of the Industrial Revolution. And so I expressed how grateful I was for the medical advances, for the electricity, for the ability to be educated, for the ability to travel. And what I saw around the table was all of the arms that had been folded defensively and all of the people who had been turning body language like this, they all started to lean forward and the arms uncrossed. And they said, "You get it. We're not the bad guys. People need energy." And I said, "Yes, people do need energy." But I said, today, we have many different ways to get energy, and we also realize there's a price tag to fossil fuels that we didn't account for back when we started this. And they agreed, and they said, "That's actually why we invited you. We want to figure out what the future of energy is." And we had an amazing conversation that went way past the allotted 45 minutes because we started with something we generally agreed on. And if we can't do that, then I don't think we can have the conversation. But that is one example of how I believe that we can. I love this. As college students, what can we do to best improve the state of our climate situation that will actually be efficient? Well, the most important thing that we can do as individuals right now is not be such an individual. What do I mean by that? I mean, we need to change the system, but a system is made up of people. How do we change a system? By being a person within the system advocating for that change. So the most efficient way that you can change our situation is by bringing others along with you to make change at scale, whether it's your floor, your dorm, your club, your class. Your university has done a lot, but there's always still more that a university can do. And hearing from students about what they could do is an encouragement to a university to continue to change. You'll be part of a place of work soon if you aren't already. You might be part of a church, you might be part of an organization or a group. When you use your voice to bring others along and to advocate for change at scale, that is the most effective and efficient thing we can do. And you know what? Every single one of us has that voice in whatever community we're in.
Dr. Hayhoe, I think we have to.
We do. These are great questions, though. I think I've answered some of these, but for more, let me give you more resources. You can find my global weirding videos online. They answer a couple of these questions right here, global weirding. You can follow me on social media. I have a website, and I have a newsletter once a week that shares a piece of good news about climate change, a piece of not so good news because we have to understand why it's bad, and something you can do to make a difference. You can find that on my website, katharineHayhoe.com. Thank you.